Hi, my name is Fong Sini. Today I want to present about Project 1, Question 1 and 2. First of all, Question 1, the equation is given is y equals to 7 minus x squared, and second equation is given is xy equals to 6. So first I make it as y as a subject, that is y equals to 6 over x, and then I build up a table for the value to plot the graph. So I plot the graph for the x-axis is 0, 0.5, 1, 1.5, and 2. And y I get is for the equation of y equals to 7 minus x squared. For I substitute the value of x, so the y for the equation x minus x squared, that is 7, 6.75, 6, 4.75, and 3. So the second equation is y equals to 6 over x. So first I substitute the same scale um, that is similar to the equation 1, that is 0, 0.5, 1, 1.5, and 2. So I substitute into the equation. I found that y, when x equals to 0, y equals to infinity. So the first value is cannot be defined, and the second value I substitute when x equals to 0.5, that I will get is y equals to 12. So from here I started to plot my curve until 2 equals, when x equals to 2, y equals to 3. So in this graph, the intersection points is when x equals to 1, y equals to 6, and when x equals to 2, y equals to 3. So um, for the intersection later, um, I will make it as the integration scale. So the question 1a is just plotted the graph. So after I plot graph, question B, it's say that I want to find the area of the region of two curves. So first I make it as the equation y equals to 7 minus x squared, and y equals to 6. So y equals to 6 over x. So for the formula of the area of region of two curves, that is the upper curve minus the lower curve. So the upper curve for this graph is 7 minus x squared. So make it as 7 minus x squared minus 6 over x. So after I integrate all the parts, that I get the answer is that I get the answer is 29 over 12 units squared. So the second questions that are given is y equals to x bracket x minus 2 bracket a x plus b bracket. So the second equation is given is x equals to 2 and y equals to 2x. So first the questions that are asked me to find the value of a and b. So first I will make it as y equals to 2x and y equals to x bracket x minus 2 bracket a x plus b bracket. I make it as the equations that is opposite sides. So I get is when I comparize the 2x components to the minus 2bx, that I get the b value is negative 1. So when b equals to negative 1, I substitute back the value of b into the equation of minus 2a plus b. Because minus 2a plus b equals to 0, so I get the value of a equals to minus negative 1 over 2. So when a equals to 1, negative 1 over 2, and b negative 1, so I substitute back into the first equation, that is y equals to x bracket x minus 2 bracket a x plus b bracket. So after I substitute all the value of a and b into these equations, that I will get is y equals to negative 1 over 2 x cubed plus 2x. So this is the final equations for this graph. So after it all, I will make it as I will find the value of x scale and y scale, because I want to plot the graph. So first I will find is y equals to 2x. So I substitute 0 when x equals to 0, y equals to 0. When x equals to 0.5, then y equals to 1. Then after I substitute all the x and y, and then I will plot the graph like this is given like shown. So after it all, I found the intersections of the 3 points, that is 2 when x equals to 2, y equals to 0. So this is the intersection between 3 points to get 3 curve together, and then I will find the area. The area of these 3 curve between is the upper curve minus the lower curve, that is 2x minus bracket negative 1 over 2x squared plus 2x. So the final value of the area curve that I get is 4 over 3 units squared. So that's all from me. My name is Feng Xinyi. My matrix number is AN240067. Thank you.
Hello everyone, today we're going to calculate the arc length of cable that hang between two poles which 20 feet apart. So first of all, we're going to use a formula to calculate the arc of length. So this is the formula to calculate arc of length. So here's a fs5 exponent x over 10 plus exponent e x over 10, and the interval is negative 10 over 10. So find the derivative of the function. So we have to use this formula, which we're going to put this formula into this formula. So we're going to get this, and the second step is to reduce the derivative. So this is the formula we're going to apply, and we're going to simplify this formula to become something like this. So the simplifier will be 1 over 4 exponent x over 5 negative 2 plus exponent x negative x over 5. And the fourth step is going to simplify the arc formula. So we have to simplify the arc formula to get the square root. So we're going to simplify it. So 1 plus 1 over 4 exponent x over 5 negative 2 plus exponent negative x over 5. And when we simplify the third, we're going to simplify this thing, and we're just going to take the square root things. So this is the result of the square root, and the last step is we're going to simplify with the integration. So this is the arc length going to become. So we have to integrate this formula into two parts. So this is the first part. So this is the first part. If you can see, we're gonna get answer 10 exponent 1 negative 10 exponent negative 1, and this is second part, which is same thing, where we just do it two times with the non-negative and non-negative and negative, and we're gonna take different answer from here. It's kind of same, but it's two different. And then the last thing that we have to do is to combine both of it in the one formula to get the answer. So this is the answer. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim Dini bin Nur Azhan. I will explain about project 1, question 4. Step 1, trigonometric substitution. The substitution x equal to 2 sin u is used from this. Dx equal to 2 cos u du. Set for minus x square equal to set for minus 2 sin u square equal to set 1 minus sin square u equal to set for cos square u equal to 2 cos u. Substituting this into the integral. Integrate set for minus x square over x square dx equal to integrate 2 cos u over 2 sin u square multiplied by 2 cos u du. Simplify equal to integrate 4 cos square u over 4 sin square u du equal to integrate cos square u over sin square u du. Step 2. Expressing in terms of cotangent. The integrand is written as cos square u over sin square u equal to cot square u. So the integral becomes integrate cot square u du. Step 3. Simplifying the integral. Using the trigonometric identity, cot square u equal to cosec square u minus 1. The integral is split. So integrate cot square u du equal to integrate cosec square u minus 1 du equal to integrate cosec square u du minus integrate 1 du. The integrals are integrate cosec square u du equal to minus cot u. Integrate 1 du equal to u, so integrate cot square u du equal to minus cot u minus u. Step 4. Back substitution. Recall the substitution x equal to sin u, so sin u equal x over 2, u equal to arc sin x over 2. Also, cot u equal to cos u over sin u equal to sec 1 minus sin square u over sin u equal to sec 1 minus x over 2 square over x over 2 equal sec 4 minus x square over x. Substitute back. Minus cot u minus u equal minus sec 4 minus x square over x minus arc sin x over 2. So the final answer is integrate sec 4 minus x square over x square dx equal to minus sec 4 minus x square over x minus arc sin x over 2 plus c. So for the equation of motion, first is with motion x direction. Initial velocity in the x direction is given as v0 x equal to 100 set 3 ms. Position as a function of time x t equal to v0 x t equal to 100 set 3 t multiplied by t. So for the northward motion y direction, the acceleration in the y direction is ay equal to 2 ms square. Position as a function of time y t y multiplied by t equal to 1 over 2 a multiplied by yt square equal to 1 over 2 multiplied by 2 and t square equal to t square. So for the vertical motion is z direction. Position as a function of time. Z multiplied by t equal to v 0 zt minus 1 over 2 gt square. Substituting values, z multiply t equal to 100 t minus 1 over 2 multiplied by 9.81 and multiply by t square. Simplifying, z t equal to 100 t minus 4.9 t square.
Project 2, question 2. Find the arc length parameterization of the circle of radius 3 centered at the origin. Standard parameterization for a circle radius 3 centered at the origin is xt equals to 3 cos t, yt equals to 3 sin t, where 0 is lower or equals to t and t is lower or equals to 2 pi. Step 2, we need to find the speed r prime t. R prime t equals to bracket negative 3 sin t and 3 cos t equals to square root bracket 3 sin t bracket, close bracket square plus bracket 3 cos t close bracket square. We get the answer equals to square root 9 sin 2t square t plus 9 cos square t. As we know from the Pythagorean identity, sin square t plus cos square t is equals to 1. So we get the answer square root of 9 equals to 3. Step 3 is we need to solve for t. T equals to s over 3. To find the final answer, we need to substitute t equals to s over 3 into the parameterization. So we get xs equals to 3 cos bracket s over 3, ys equals to 3 sin bracket s over 3, where 0 is lower or equals to s and s is lower or equals to 6 pi. So the final answer is the arc length parameterization of the circle is xs equals to 3 cos bracket s over 3, ys equals to 3 sin s over 3.
So for the third question, a cable is to be hung between two poles at equal height that are 20 feet apart. In this case, suppose that the cable takes the shape of y equals to 5 times exponent to the power of x over 10 plus exponent to the power of negative x over 10, and with the limit of negative 10 equals all over to x, and x equals all over to 10. So how long is the cable? So first of all, we can use the formula, which is the formula of the curve of the arc, which is L equals to the integration from a to the b times the square root of 1 plus dy over dx squared dx. So first of all, we need to find dy over dx. We can insert the value which is given, and then we will get 1 over 2 times exponent to the power of x over 10 minus exponent to the negative x over 10. After that, we need to find dy dx squared. To do that, we just find the answer, which will be 1 over 4 times to the exponent to the power of 2 x over 10 minus 2 plus exponent to the power of negative 2x over 10. After that, we need to find 1 plus dy dx squared, which we will get 1 over 4 equals to 1 over 4 times exponent to x over 10 plus exponent to the power of negative 2x over 10 plus 2. After that, we can just insert the value into our formula, and then we can just type it on the calculator, and then we will get 23.5 feet. That's all.
Project 2, question 4. Find the binomial vector bt for the curve traced out by rt equals to sin t, cos t, and t. Step 1 is to compute the tangent vector. So we get r prime t equals to d over dt sin t cos t and t equals to cos t negative sin t and 1. Step 2 is to compute the normal vector nt. R prime t equals to square root bracket cos t square plus bracket negative sin t square plus 1 square. We get the answer square root of 2. Now we can find the unit tangent vector t bracket t equals to r prime t over modulus r prime t equals to bracket cos t over square root of 2 negative sin t over square root of 2 and 1 over square root 2. Step 3 is to compute the derivative of the tangent vector. Now differentiate t to find t prime t. T prime bracket t equals to bracket negative sin t over square root of 2 negative cos t over square root of 2 and 0. Step 4 is to compute the normal vector nt. First, find the magnitude of t prime t, which is square root of bracket negative sin t over prime square root 2 square root 2 and step 4 to find the magnitude of t prime t equals to square root of bracket negative sin t over square root 2 close bracket square plus bracket negative cos t over square root of 2 square plus 0 square equals to 1 over square root 2. Then the unit normal vector nt is equals to t prime t over modulus t prime t equals to bracket negative sin t, negative cos t, and 0. Step 5 is compute the binomial vector bt. bt equals to t bracket t times nt. We have the t bracket t and the nt, so we need to compute the cross product. bt equals to modulus I jk cos t over square root 2 negative sin t over square root 2 1 over square root 2 and negative sin t minus cos t and 0. Calculating the determinant gives bt equals to bracket sin t over square root 2 cos t over square root 2 and 1 over square root 2. That is the final answer. Thank you.